afternoon, everybody, and I would like to thank Bernard and Massimo, specifically, and Sigmafine for us to give us for this opportunity to present our solutions. Just a small correction. Micromotion is our brand, yes, and we mainly call it Flow Solutions created by Emerson. We recently changed this and combined the group, so I just wanted to make that. But it is very, very well known as Micromotion in the market, if you know Emerson products. So after all these software discussions, again, a new technology, but I just would like to help you to step into the field in your facilities a little bit. We will discuss about, I will try to present about role of field instruments, then the importance of accuracy in production, accounting, and losses in mass balances. What are the business challenges? How we can identify the measurement issues together with Sigmafine software, and what are the current measurement technologies, and at the end, some recommended best practices for improvement of mass balance. So when we look at the production accounting, various people from your facility, specifically refinery, has been impacted with mass balance calculations. If you look at upper management or process supervisors or operators, all of them has different level of KPIs regarding to production accounting and loss management. And for a based on our experience in the market with poor instrumentation and procedures, the mass percentage of mass on loss is 1.5 or 2.5% overall, and with an average instrumentation, it's between 0.7 and 1.5%, and with a good instrumentation, the mass balance closure level within the refineries is around 0.5%. And you must be familiar with the specifically refinery people are familiar with the Solomon index reporting. If you would like to have a good Solomon's index reporting for mass balance, it's expected to be less than 0.5% for an overall refinery mass balance mass loss level. So why mass balance that matters much? Because one of the first three things we can identify. One of the first is profitability. So nobody would like to overpay for a product or underpaid for a product they sell, right? So the second thing we can say health, safety, and environmental. Specifically within Europe, it's much more strong than other world areas nowadays because of emissions. Nobody would like to pay fine. We wouldn't like to pay fine. So that will also help you to know what is your carbon dioxide level and other emissions level. And the third thing is process optimization. In addition to the refinery-wide mass balance, facility-wide mass balance, if you think about other units within your refinery, to optimize all level by learning what is your inputs and what is the level of your outputs, hopefully help you to optimize your process. So again, sorry. Again, when we look at the refinery loss control process, there are three main things that we see so far. One of the first thing is measurement. Obviously, Bernard mentioned in the morning, the raw data is the first process. The second thing is business practices. How do you operate your facility is one of the important processes, and the other one is, as we are all together for this, you are using Sigmafine for the data reconciliation software. Mainly because it's just in front of the evaluation, data evaluation, and gives you the information of your mass balance level, the business practices, the operational practices, and data reconciliation software is what the refineries and the operators are looking for, and underestimating the importance of the raw data sometime, and that is where the measurement is all about. I will give a little bit more detail. So when we talk about mass balance, let's say losses on the mass balance closure level, losses could be unaccountable and accountable. This example is maybe you have seen in the news. At the Shell refinery in Singapore, within a long time period, small amount of product unloaded or loaded from the jetty was stolen, and there were some Shell employees and also the ship personnel was involved, and around $150 million worth of oil was stolen. So this is one of the unaccountable losses. Obviously, the theft. If you cannot measure accurately, you will not be able to understand what's going on. So Shell already has taken the measures to avoid this type of incidents to increase their measurements for mass balance calculation. So the main challenges that we have seen so far is the data entry errors, which is mainly manual entries of the data. The second thing is the measurement errors. We will get into the details, but we can say accuracy of the instrumentation, maintenance and calibration procedures, practices being applied in the refineries, and changes in process conditions. And the other thing is the missing data, which means maybe you are not getting the right information, right amount of raw data from your facility. So when we look at the process conditions differ from design conditions, we discussed about the measurement data issues. Most of the refineries, specifically on the refinery perspective, most of the refineries are old facilities, and if you are using your instrumentation based on its design conditions, obviously it has been changed during the time, and the process conditions nowadays could be different from the original design conditions. Second thing is volumetric measurement. Volumetric meters requires, depends on some changes specifically on density, and facilities like refineries, density mainly change during the process change. And the third thing is, as we do mass balance, online density is required specifically if you are using a volumetric measurement. That's why you need to have a really accurate density measurement and online density measurement. If you are using lamp density, obviously that may be changing over time when you apply the calculation. This has also been shown during the day. You may be looking at the Sigmafine and at the software and mass balance calculation perspective, but I would like to take attention to look at an instrument, the meter itself, from the meter's perspective. By looking at some statistical data or meter corrections, obviously the Sigmafine software dashboards can help you to understand the evolution of the meter during its life cycle, and whether, as I have just mentioned, some challenges, whether the accuracy of the meter has changed or not. So by just looking at it, you can still understand by data evaluation, as said, whether the meter has a good condition or not. So another main point of using a software like Sigmafine, if you look at the down below, error minimization. So, and when you look at the calculation, no, it doesn't work. So when you look at the calculation, raw data minus reconciled data divided by absolute tolerance. So if you can increase the accuracy of your raw data, obviously it will in fact your error minimization via using your data reconciliation software, Sigmafine software. Quickly, I just would like to mention, and we'll get back to this at the end of the presentation. When you look at the data quality KPIs via Sigmafine, you have some main redundancy is one of them, imbalance, tolerance is one of them. So, and redundancy is one of the most important data, let's say, validation within the mass balance closure calculations. And just sorry, you already know this. So, and when you look at the benefits of Sigmafine for this perspective, you may be looking at this as an indirect benefit of Sigmafine for a software perspective, but when you look at a metering perspective and an instrumentation perspective, obviously you can easily see on the chart the evaluation of the number of the bad meters. So this chart on the left is the percentage of the bed meters, and at a certain time period, you see how the number of the bed meters or the percentage of the bed meters decreases. So Sigmafine still can give you a direct information about your mass balance closure in that perspective. So these are the main challenges, and I would like to give some information about the solutions that we can provide to measure your products, to meter your products accurately. If you look at the cassette transfer measurement types and applied within the facilities, within refineries, obviously mass and volumetric flow meters, as we discussed. Automatic tank gauging systems are already used. Marine vessel gauging could be a little bit different than the inside measurement systems, metering systems. Manual gauging is used. Truck loading and rail car loading are also one of the main metering points in the facility, and weight scales are also commonly used. If you start with the flow meters technology, refineries are around 150 years old, so flow metering is also a little bit old, and based on a survey, differential pressure products are one of the most common used in the refinery, and almost 100 years it has been used. There are magnetic meters, Coriolis meters, relatively 30 years in the market, turbine meters and positive displacement meters, mechanical meters in other terms, and some other ultrasonic meters and vortex meters are already used in the refineries as the flow meters. I will just try to give you some example of one of the challenges about traditional metering and versus the new type of metering via Coriolis meter, via Micromotion as our brand. So if you look at the best existing situation in the traditional metering, and as just mentioned, the design process specification when the facility is installed, and nowadays process conditions, what has changed. As said, as just shown in this graphic, differential pressure is and also turbine and the positive displacement is very well used. If you look at the DP meters, orifice DP meters, it's very great application. It has very great application flexibility and very well low purchase price. But there are some limitations in the market for DP meters. It has poor accuracy if you do not compensate it, and to compensate it, you need to know the fluid density very well. That's one of the most important things, and it will give you a moderate accuracy of moderate accuracy for your instrument. And the other thing is you need to maintain it properly, otherwise the accuracy degradation could be really impact your accuracy level. And when we look at the mechanical meters, which is mainly volumetric meters, it requires high maintenance, and also there may be meter factor shift, so you need to frequently check and adjust the mechanical meters. This is where we call as traditional metering in the facilities. But nowadays, and for the last 30 years, and it's very well accepted in the market, Coriolis meters, as it is also the mass measurement, direct mass measurement, and also with the density measurement option, is very well accepted within the market. As said, Coriolis meter has direct mass and density measurement. That is why it's not affected by the changes in the composition, like viscosity, temperature, pressure, and conductivity. It has great range of great range for custody or non-custody measurement, and also very high accuracy. Mass flow rate 0.1% accuracy, volume flow rate 0.1% accuracy as well. There is no flow conditioning required. Other volumetric meters requires a long upstream or downstream piping, and you can measure liquid, and we are also suggesting to use on the fuel gas applications. So it's a very broad range of possibility to install in your facility. It has natural bidirectional measurement, and very much important thing is you can, up to a certain level, which is 5%, you can measure two-phase flow. I mean, some gases within the liquid and specifically Emerson Coriolis meters can identify dead gases and correct itself. And how we do that? We call it smart meter verification. So, sorry, I will directly go to the smart meter verification. So smart meter verification is mainly a diagnostic tool approved by any third party that you can require. For Europe, it's approved by NMI. And you can use your smart meter verification for any changes in your sensor calibration, like accuracy or flap calibration factor or any stiffness changes, any changes on your electronic performance, any failure on the electronics, changes on the configuration, and any changes on any effects due to the process changes. It will give you an alarm, and it will give you if there is really a warning required within the Coriolis meter. So that is one of the main differentiator for Coriolis meters for the long-term stability. And as I just mentioned, it has a really long-term stability, and you can see after 5 months of operation, there is a comparison between the Coriolis meter and also turbine meter, and you can see the change on the meter accuracy after 5 months operation, Coriolis versus turbine meter. So, and it is, as said, very well accepted on any types of standards and regulations you may require. I can say Emerson started around early 80s to sell Coriolis meter, and it was 2015, if I'm not wrong. We have sold 1 million Coriolis meters, so it's right now I'm expecting something around 1.5 million or so. Just give another example. Even on the ships, on the tanker lightering, Coriolis meters are used to to measure the fuel oil specifically they use for the ship itself. So in addition to the, we started with the metering. In addition to the Coriolis meters, at some cases within the refineries, it's not easy to find out unaccounted losses, like then let's say accountable loss, which is a flare applications. It's not easy to measure, and specifically for the high temperature, we are not able to use Coriolis meters, but we are working with another company together, and we are using ultrasonic meters because because of the different processes, obviously the gas may change, the gas within the flare may change. That's why there is too much uncertainty. So it is very important to accurately, or it's very difficult to accurately measure the amount of the gas within the flare. And as mentioned, instead of the Coriolis meters, ultrasonic meters are very well used for flare measurements. And in addition to this, obviously you need to, for your product accounting, you need to check your inventory. And for the inventory tracking, the most common application right now is automatic tank gauging systems. And when we look at an automatic tank gauging system, you require a level measurement, you require a product temperature measurement, you require density measurement, you require if there is any sediment and water, you need to separate that, and one of the most important parameters is tank strapping table. And nowadays, Emerson as a group, Rosemont tank gauging system, if you look at the accuracy of automatic tank gauging, and if you look at the accuracy requirement within the market, like PTB in Germany, NMI or API, and it has been on the chart, the tank gauging, the tank radar accuracy is way better than all these requirements, as you can see on the chart. So what makes then tank gauging or automatic tank gauging system uncertainty important? So it's not only the tank radar system that you use, it's not the instrument itself. You need to also think as a system. And when we look at as just mentioned in the previous slides, level measurement, temperature measurement, and other type of requirements, So tank gauging system installation method is very important. So uncertainty in the tank capacity table, which means you need to maintain your stepping table properly. So obviously Sigmafine is helping you on this to enter your data within the software and calculate the level of the stepping, calculate your temperature, tank gauging level. But in any case, the stepping table needs to be maintained properly. And the other thing is product temperature. You need to take your temperature on a multi-spot on a big tank. It wouldn't be accurate if you take the temperature measurement on one point. You need to take multiple points to get the accurate measurement and decrease the uncertainty level. And the other thing is, as just mentioned at the beginning of the presentation, density measurement. Because you are measuring a volume, you would like to change it to convert it to mass because you are doing a mass balance calculation. So the density is also important here for your calculation. So how to improve the mass balances? First of all, obviously, you need to evaluate your current closure of your mass balance. It could be your refinery-wide mass balance, facility-wide mass balance, or it could be a unit within your refinery or a chemical facility that you would like to do the mass balance, which will affect the overall mass balance, obviously. And Sigmafine, obviously, as just mentioned with the dashboards and the KPIs, Sigmafine will definitely help you to identify your measurement issues, specifically using the KPIs that we discussed. And if you look at very briefly to the critical balance points to prioritize for a refinery, crude import point is the most important thing, crude charge to the crude unit, conversion unit, feed rates, primary products for accurate yield data, and unconverted bottoms on the process units. And how we can help? We can start to perform an audit within your facility, specifically on the measurement points, and we can help you to identify or make a plan for your mass balance improvement level. So, key takeaways for me today. Thank you again for Sigmafine to have this opportunity for us. For a mass balance, calculation or mass balance study, you need to understand where are the missing and inaccurate measurement points. And as said, Sigmafine can definitely help this. The traditional technology in mass balance applications can cause inaccuracies that you underestimated. You may underestimate it, let's say. And accurate data is very important for data reconciliation, reducing losses, and optimization of your process. And Emerson, together with Sigmafine, is ready to help you for your mass balance improvement anytime. Thank you. This was my last slide.